2. P is a variable point on the line 3x minus 2y plus 10 equals 0. Tangents are drawn from P to the circle 2x squared plus 2y squared plus 4x minus 4y plus 2 equals 0. Show that as P varies, the chord of contact of the tangents pass through a fixed point and find its coordinates. Right now. Then, this is the given line with the equation 3x minus 2y plus 10 equals 0. On this line, people, we have a point P. We have a point P, right? Okay, this point P is a variable point. That means the point P moves on the line here and there. That's the meaning of the point P is variable point, right? And from there, from the point P, tangents are drawn to the circle this given. Given circle is this given. I take the two given circle, the given circle is this. Its equation given as 2x squared plus 2y squared plus 4x minus 4y plus 2 equals 0. Right, I divide that equation both sides by 2 and then I write its equation. Then the equation we get of this as this way. X squared plus y squared plus 2x minus 2y plus 1 equals 0. I divided this given equation of the circle by 2. Right. Now from here, people, two tangents are drawn to the circle like this. Two tangents are drawn to the circle like this. Now the two tangents contact the circle at 2 points. The two contact points, people, we can join by a line. That line only we define as chord of contact, right? This is a chord of contact. Now, asking us to prove what, people? When the point P moves on this line here and there, okay, this line, the chord of contact, passes through a fixed point. Right? Then, I will work out that question like this. Okay, people, I am going to take of the point P the exponent as alpha. I am going to take the exponent as alpha of the point P. Then putting that alpha here, I can find y. Then I get, putting alpha here, subjecting y, we get y equals what, people? 3 alpha plus 10 by 2 is your y. Then this is 3 alpha plus 10 by 2. Right now, if x coordinate of the point P is alpha, y coordinate can be found substituting that alpha in the equation of the line. Now, we know the equation of chord of contact to a circle from a point P x naught y naught. We know, people, that third part we did. But the third part, if the circle is this, the standard circle, this way, from a point P x naught y naught, when we construct this way two tangents, and the equation of chord of contact, can you remember the way we wrote? It is, we write this x squared as x into x, y squared as y into y, and this 2gx as how, people? G times 2x, that 2x we write x plus x, and this 2f5 we write f into 2y, 2y we write y plus equals 0. Right? Now, I put for 1x the exponent x naught for 1y, y naught. So then we get x naught plus y naught plus d times x plus x naught plus f times y plus y naught plus c equals 0. This is the equation of this code of contact. Using that theory, now you can write the code of contact this. Okay, right now. Then code of contact I can write using this theory like this. I write this x squared dash people x into x, y squared dash y into y, and this 2x as x plus x, right? And minus 2y, y plus y, and plus 1 equals 0. Plus 1 equals 0. Okay, now that x coordinate alpha here and y coordinate this one we are here, we have substitute by using this theory. Okay, then we get the equation of this code of contact. Right? Yeah. So once I write like that, we get alpha we put for this x, alpha x plus next one is 1y we have put that 3 alpha plus split by 2 times y, right? And alpha plus x here, and here y times the other y we replace by 3 alpha plus 10 by 2, right? Plus 1 equals 0. People, in this case, you can very clearly understand this alpha. Alpha is a variable. Alpha is a variable. Why people? This point P is a variable point on the line now. This point P moves here and there on the line. As a point P moves here and there on the line, its x coordinate changes, people. That means alpha changes. Therefore, alpha is a variable. In other words, alpha is a parameter. Parameter. The reason is what, people? What is the difference between the parameter and the variable? You know, P is a variable point, that's true. Right. When P varies from here to another point on the line, for that point, there is a definite value for this alpha. If the point P is there without moving, then the alpha is a constant. Now, alpha changes to new value if this point P goes to new position. So, therefore, such variation, of course, we identify as a parameter. Then this alpha is a real parameter. Okay? Alpha is a parameter. Right. Now, what I am going to do is, people, here, I am going to collect alpha terms together from here, other terms separated together. So, when I take alpha terms together, right, I get this P, alpha. Here we get alpha out, the next, and here we get 1, okay, and finally we get this way, after taking this alpha out, this kind of expression we get inside the bracket, alpha is outside, and the other terms, independent of alpha, here we get 10 by 2 is 5, here x, here minus 5, and there 1. Then by them of course we get like this, x plus 4y minus 4. This way we get the right hand side equals 0. Ten by 2 here we get, no, that's right. 10 by 2 there we get 5 minus 4, right. This way an equation coming, people. This alpha is a parameter. We are alpha is a parameter. Alpha is a parameter, right. Now this is the equation of what? This code. Now you can see very clearly that equation takes the form L1 plus lambda L2 equals 0. Here you can see, if I take this one, here this is an equation of a straight line. X term, y term, constant. If I take this as L1, this as L2, right? That's also equation of a straight line. Then this equation of the code of contact takes the form L1 plus lambda L2 equals 0. Then you can write this takes the form L1 plus lambda L2 equals 0. Because you know, in the theory part, in the straight lines, L1 plus lambda L2 equals 0, such equation where lambda is a parameter represents what? Any straight line passing through the point of intersection of the straight lines L1 and L2. So therefore, by using that we can say this code of contact passes through the point of intersection of this line and this line. Therefore, people in this case, in order to say by this equation that gives any straight line passing through the intersection of this line and this line, you have to very clearly see there, right? L1 line and L2 line are not parallel. If they are parallel people, they never intersect each other. Then the expression we are going to say is wrong. So, very obviously you can see here, the gradient of this line is equal to what? Minus 1 upon 4. Right? Here, different from there. The gradients are not equal. Therefore, definitely the lines intersect each other. Okay? This takes the form L1 plus lambda L2 equals 0, where lambda is a parameter. Lambda is a parameter and L1 not parallel to L2. L1 not parallel to L2. Right now, L1 not parallel to L2. Right. So, okay, now you can say here in this way what we do. Right now you can say, since this takes the form L1 plus lambda L2 equals 0, where lambda is a parameter and L1 and L2, right, not parallel, you can say this kind of equation gives any equation which passes through the point of intersection of the two lines, this and this. So therefore we can now say this code of contact passes through the point of intersection of this line and this line. Then the line, this and this line, these two lines are equal to fixed lines, two fixed lines. Therefore, their point of intersection is fixed. So therefore, that code of contact passes through that fixed point. That's how we prove. Then it's very important to say here, people. This takes the form L1 plus lambda L2 equals 0, where lambda is a parameter and L1 not parallel to L2. Then only we can say the code of contact passes through the point of intersection of this line and this line. Correct now, people? Right? Then you can write. Therefore, the code of contact passes through the point of intersection of x plus 4y minus 4 equals 0 and x plus 3y by 2 minus half equals 0. Right? Now you can see this line and this line are two fixed lines. Therefore, the point of intersection of them being fixed, therefore the code of contact passes through a fixed point. Okay? Alright. I think right now. Therefore, the code of contact passes through a fixed point. Passes through a fixed point. Right, then that fixed point is people the point of intersection of the two lines. So now to find the point of intersection, we have to solve these two equations simultaneously. We have to solve these two equations simultaneously. Right? Fixed point we can now find. Solving x plus 4y minus y equals 0 and this. So these two equations people, then you get x and y values. By x value we get x coordinate, by y value we get y coordinate. Right now? Yeah. Then you get answers here. With the difference, what do you get here people? X and x get cancelled. 4y minus 3y by 2 plus half minus 4 equals 0. Then here we get 8y minus 3y. 8y minus 3y is 5y by 2. And here, once I do this right hand side, we get 7 by 2. No? Then y comes as 7 by 5. The next we can find substitute that value here. Then you get the x value minus 8 by 5. No? X value minus 8 by 5. X can be found here. 4 minus 4 times 7 by 5. Minus 28 by 5 minus 8 by 5. Therefore, fixed point. Fixed point is what we minus 8 by 5 and 7 by 5. Minus 8 by 5, 7 by 5. That's how we take an answer.